Does this seem hipster enough? I'm wearing my comms. I've got my GitHub t-shirt on. No? My kids are not skipping. Oh. Alright. I've got some coffee. I've got some good, like, fair trade. Enough? No? Me? No more? I got my flannel shirt. Good? I'm getting close. You know, I tried working on that earlier today. It didn't work out very well. No. Pick up a PDR. Okay. Short of that thing to get a tattoo on stage. So I think we're pretty much as good as we're going to get. Let's play some bright eyes for everyone next. Okay. So that was my visual gag to lead into my talk. Hope you enjoyed it. I'm Scott Roberts. That's me and a very adorable little puppy dog who I will happily give to any of you if you'll put up with him. I've been working at GitHub since about 2012. I've been doing Deeper since about 2006. I've been a Mac user since 1989. How many people are meeting me? 2, not bad. You guys have PDRs if you want them. And I've been curious since 1983. I put up this slide so you know that I've done stuff at places you've heard of, so you trust me when I tell you to do stuff. I've done a lot of side work, some threat intelligence work, and some deeper work as well. This was my first computer. Can anybody identify it? It is the 2C. All right, good. I do presence and response at GitHub. So we have I'll talk a little bit about GitHub and kind of the environment we have, but I essentially do any type of investigations into customer issues that GitHub is involved in, attacks against GitHub itself, all of that. So we're going to talk about incident response with Macs. And we've all read marketing. Well, why? I mean, Macs don't get hacked. We've been told that for long enough. You just push this button, and you don't get hacked, right? You guys all have this one, right? No, okay. It turns out not enough people have that button. There have been some pretty big vulnerabilities over the last couple of years. Apple rode for a long time of basically being unpopular, and as a result claimed they were secure. And it was really more of an issue of opportunity than technology. During the Snowden documents, we saw that the NSA and CIA are interested in attacking iOS, OS X, the whole dropout Jeep thing. Dropout Jeep? Dropkick Jeep? I don't remember. Dropout Murphys? No, that's something else. And then we've even had some of the bigger name companies that are primarily Mac focused, like Apple, like Facebook, like Twitter, get compromised. This was a really interesting one. An Apple developer forum was used as a watering hole. So Mac attacks are actually a thing, and they're on the rise, really, as market shares on the rise. And I think it goes beyond that. I think it's also the fact that Macs are typically found either for people working in coffee shops, or research, or finance, or education, or a lot of other places that if you're a nation-state attacker might be kind of interesting. And as this market share has been going up, there's a problem, which is the industry hasn't really caught up with it. We still kind of think of Macs primarily as consumer-level tool, and so if anybody's gone shopping for enterprise-level security tools for Mac, you get a lot of people who are like, oh yeah, no, we support Macs. We can read HFS+, which is the file system, or we have a application that will run on Mac. But in most cases, Macs are just kind of a second-class system. And so that was sort of why I wanted to do this talk. Let's just talk about it. And I told a bunch of people about my talk, and I realized it was kind of confusing. Bless you. Because when I say deeper on Mac, it's really a question of what do I mean? Do I mean deeper using a Mac as your investigation platform? Or do I mean your to analyze being a Mac? And the answer is I need both. I've worked in a bunch of places where we did Windows investigations and use Macs. You know, it's nice when your main platform can't get infected by the malware you're currently analyzing. And so there are tools like Cuckoo Sandbox, which are really awesome for doing incident response, but don't honestly work very well for Mac incident response. But GitHub can do both. So I'll tell you a little bit about GitHub. Sorry, has anybody heard of GitHub? Okay, great. We're a t-shirt company. We're getting into Git hosting. I think it's going to be big. So when I came to GitHub, I came as a forensics incident response. There were three challenges that we had when it came to doing security operations at GitHub. Location, platform, and attitude. So from a location perspective, this is an active map of where GitHubbers are by country as of September 9th. So 54% of GitHubbers were remote. As you can see, we cover a decent number of time zones, countries, legal jurisdictions, everything. And that's a challenge because a lot of the forensic practices people go through are very reliant on hands-on. I've never actually had to deal with it, but I've heard horror stories of trying to do chain of custody where you say, and then you put it in FedEx. That's not going to go well. But we have to be prepared to do everything we do to analyze compromises remotely. And in some cases, not even with someone who's technically proficient. We have some challenges when it comes to platform. I mean, we're going to talk about OSX. From the desktop perspective, it's a little bit of a rounding error. We're 100% an OSX shop. And then on the data center, we're 100% Linux. We have, I think, 3 or 4 Windows boxes, and they're all used for testing. So, that's a challenge because most of the commercial tools that are coming out are specifically aimed at Windows. This is improving a little bit, but I still think it's a pretty safe thing to say, Windows first, everything else second. And thirdly, we have a different attitude than most places I've worked when it comes to how we do security. We focus very much on trust and openness and transparency. Our users really work under the idea that we're not watching them, we're not spying over their shoulder, there's no big brother. And if we don't maintain that rapport, we're going to lose a lot of our visibility and things like that. So we can't do some of the draconian things that I could do when I worked at, say, a base spooky defense contractor. And just as a bonus, we really like open source stuff. It's kind of surprising given we host a bunch of it, but we definitely use paid tools, but we always like to default to open source and free tools. So those are the challenges that I kind of came into when I started working in incident response at GitHub about 3 years ago. And to be honest, I had not worked as doing incident response on OSX at that point. So here are a couple of concepts you're going to need if you're going to do. How many people are OSX users? Okay. Then some of this will be new to some of you. Great. And this is just, some of the important concepts that if you're used to doing forensic incident response on a Windows platform, are going to be a little different on Mac. You're going to see NEX and NS everywhere. This is kind of a history lesson. There was OS 7, old school Mac OS, released in 1991. Come about 1995, Microsoft was releasing 95, and Apple did some crazy stuff to try to keep up. If anybody has like project management, it's a great example of scope creep gone horribly awry. Because that operating system project called Copeland spiraled out of control, and their next generation OS at Apple just fell apart. So they bought a little company called Next. So anybody know who the CEO of Next was? Steve Jobs. And basically took everything from Next and literally just made it OS 10. And that's where we got OS 10 from. So next is everywhere because next. And NS is actually next step, which was their development environment. So you'll see that sprinkled around everywhere. I put lots of fun hipster photos in the background, by the way. This, in case you're wondering, it is a chalice mason jar. I don't know why. So ArchCon is weird to work on because it's Unix except when it's not, and it's Windowsy, except when it's not, and it's just completely OS 10. So it was built on a Unix core, we're going to talk about that in a second, that then it is bolted a bunch of Windows stuff on at the point where Apple's market share was so low they were doing anything to get anyone to use one. So when you're doing instant response on Mac, the first thing you learn to love, and I'm going to say this word a lot, and we're going to make a drinking game out of this talk, plist would be the word to use. Plist are property lists, and they're the configurations format that Apple uses for everything. If you're doing instant response on a Mac, a lot of the changes, a lot of the things you're going to be looking for are going to be stored in plists. Apple definition for this is, the key bit is these types of means to produce data that's meaningfully structured, transportable, storable, accessible, and still efficient. That sounds awesome, but what does it mean? Most of the time it means binary files, and then a lot of times it means XML and JSON. These are everywhere. They're used by the operating system. They're used by application writers. They're everywhere. So this is what an XML-based plist file looks like. It's just a series of keys specify the type of value. If you want to look at the binary ones, you're only going to be able to do it using Xcode. So get used to this interface. You'll see it a lot. There are a couple tools that we'll talk about later that do parse binary plists, but it's a janky hack that even Apple says you really shouldn't do because they don't really want you poking around in plists. Mako. Does anybody know Mako? Huh? Okay, you do a weird with that, but that's not why. Yes, the Mako kernel. So, I said it's kind of like Unix, and it is kind of like Unix, but it's this weird derived BSD kernel called Mako, which is just everywhere and everything, because Mako and the binary file that it does for applications works on 32-bit, 64-bit, PowerPC, Intel, ARM, everywhere. So both the kernel and the file format are going to be something you'll get used to quickly. HFS Plus is Apple's file system format. It's what everything since 10.3 has been on, I believe. Weird little thing about that. Max file size, 8 exabytes. Max file system size, also 8 exabytes. So I guess you could have a one-file system if you really felt that was necessary. It's a different file system, but for all intents and purposes, it acts a lot like ext2 or ext3, Unix style permissions. Most ways it kind of acts like that. Kernel extensions, fantastic annotators. Kernel extensions are kind of what you'd expect them to be. They're Apple's version of a kernel module. These are things that run at ring 0, start up at the beginning of the boot process. Typically, you're going to use them for either malware or VPNs, antivirus, things like that. The last two Apple applications to know about are Gatekeeper and XProtect. So Gatekeeper is Apple's code signing system, which got to be a lot more stringent when the App Store integration came out. So, for instance, right now, if you boot up a new Mac and try to run an application by a developer Apple doesn't know about, it just won't run. And you can turn that down a little bit, and then it will run. But their code signing is getting a lot less stringent than Windows, but getting more stringent. And then XProtect is Apple's incredibly minimal AV system. By which I mean, I think it's got about 150 signatures in it right now, which does represent most of the Mac malware that's out there, but pretty small. And the last sort of concepts I'm going to talk about are persistence mechanisms. Because I mentioned it's like Unix, except where it's like Windows, except where it's OS X. And unfortunately, that came about most clearly in persistence mechanisms. So you can do cron jobs on Apple because it's a Unix box. You can do kernel extensions because kernel modules, kind of Windows, Linuxy sort of thing. You can do launch statements, which are the most common way for system-level OS X tools to start up. And they're started at the very beginning by launchd, described by a plist, in case you were curious. And then there's a series of deprecated ones. So you can still use startup items, where essentially if you have the right plist and a script in either of those two directories, they start up at boot without anybody asking. You can do login items, where users can specify, I want this visual app to start up at boot time. Login hooks, this one was used by the iPhone SDK attack, where all you actually have to do is ask the operating system at login, run this script. It'll do that for you. It's incredibly helpful. And finally, they just added this, really turned it up in 10.10, where applications will just restart for you when you reboot your Mac. It'll just go back to the same state you were at. So this includes weird things like Chrome will go back to the exact place you were when you rebooted, which is useful, but also useful from a malware perspective. And by the way, I've actually skipped a bunch of other options like persistence via rc.common, app-specific techniques, binary infection, inserted libraries. There's actually, this is probably the most frustrating thing about doing OS X analysis, is there are so many different places bad guys can tell their malware to come back on restart. The Synac team did a really good research paper on OS X persistence, and they listed about the other, I think they had 8 more that aren't working anymore, but it's a little bit more complicated than just going to a registry key. So the name of the talk, I promised tools. So I'm going to give you some cool tools. That is a hipster with a selfie stick, and that's as big a tool as I can find. But I'm going to kind of talk about the tools in terms of, and again, all these should be centric to OS X. Alerting, triage, forensics, malware, and then finally reporting. It's kind of how I divvy up the tool system. So, how do we find possibly compromised hosts with alerting? How do we see if they are compromised with triage? The rest, I think, are self-explanatory. So, most Linux tools will work under OS X. This isn't a 100% thing. I've definitely sat there for hours trying to get something to run that totally should run, and I don't know why make isn't working. But for the most part, you can rely on Linux tools being available in some format on OS X. That being said, one of the things that is actually really useful from an incident response perspective is that OS X does do a really great job of supporting VMs in a lot of different ways. So VMware Fusion and VirtualBox are 2 pieces of virtualization software. But then there's also extra things around it like Docker and Vagrant. I don't know if anybody uses Vagrant. Super useful because it lets you basically describe a virtual machine environment, and then all you say is Vagrant up, and you come back in 30 seconds and you have that environment waiting for you, including installed applications, configured networking stuff, things like that. So if I want to go visit a malicious website, it's Vagrant up, create some brand new VM, and have all my tools, there waiting for me. Super handy. I know a lot of people were using Ansible, which is kind of a lighter weight Puppet or Chef for scripting VMs in VirtualBox or Fusion. And this really allows you to support, that on OS X you can essentially run everybody's tools, as opposed to using Windows or Linux, where OS X tools are pretty much just completely unobtainable. There's a bunch of built-in tools that are useful when you're analyzing a Mac. This one's not technically a tool for location, but bar log on OS X is amazing. Apple's really consistent about forcing both themselves and developers to do serious logging and generally to bar log. If you go look at your own Mac and just poke through bar log, you'll be amazed how much is in there. They also built in this nice little console tool that parses the major file versions, the major log files that are in bar log. Lets you search, lets you flag, lets you do a bunch of different just slicing and dicing on individual files. You can also use Activity Monitor for more of a ProcMon, SysMon type application. And somebody asked me when I was kind of showing off this talk before about, well, use ProcMon and SysMon, you don't use the built-in tools because most Windows malware tries to hide from the local tools. And the weird thing about OS X is there's still such a limited number of attacks that, especially for the commodity malware, they don't even try to hide. So most of the time you can just pull up your system-level tools and see artifacts right there for you. I also do like this guy's computer. This sister playing guitar is using a Mac, which I think is double points. Not technically built in, you actually have to install them, but Xcode and Dtrace are two tools that for doing OS X response I think are really useful. Xcode is Apple's developer suite. It's built for development, debugging, instruments, lets you do performance monitoring, and a bunch of different Dtrace type applications. It also gets you command line tools like an updated version of Ruby and Python. This also is the only way to get the native binary plist viewer is by installing Xcode. So definitely worth taking the time. You get typical Linuxy goodness like stat and LSOF. So everybody remembers their LSOF? Guys, what everybody forgets about? Offset and grep, fairly common, incredibly useful. I read a lot of my own tools using Python or Ruby, both of which are supported out of the box on the Mac. So that's a bunch of stuff that's built in. Some tools that I think are worth looking into that are not necessarily security tools, but super useful for investigations. Okay, Homebrew, and I put coffee behind it because it's brewed. You guys need to go get a drink or something. Well, thank you. Thank you. If you're using a Mac and you're not using Homebrew and Cast, first of all, you're already hurting yourself because they're two really awesome applications. But a lot of the really common security tools are also supported by Homebrew and Cast. So Homebrew is for installing command line tools in a programmatic way. So, brew install nmap, and all of a sudden you have nmap on your machine configured, ready to go, waiting for you. Cast is a bit newer. And Cast does the same thing, but specifically for GUI-based applications. So, for instance, you could do brewcast install Maltego, and 30 seconds later you'll have Maltego sitting on your desktop waiting to be used. Super useful. 90% of the security tools I use commonly can be found in Homebrew or in Cast. So, not really a security tool itself, but useful. Who's heard of JQ? Okay, this is the cool one. Take this home. It's so minor, but it's so useful. JQ is basically grep for JSON files. So GitHub does almost all of our logging and things like that directly to JSON. A bunch of the tools I'm going to talk about later output directly to JSON. And what JQ lets you do is grep that specific to the structure of a JSON file. So, there's not a whole lot of command line options and things like that. But when you have this, and JQ turns it into this, that's really nice. Here's an example, and it's way at the bottom, unfortunately. But I captured a JSON file and used JQ to turn it into a CSV file that I can then dump into another tool. And we're talking a 32 meg JSON file, and this runs instantaneously. That's a really useful little tool. Highly recommended. I don't actually use it much, but Apple has a remote desktop tool that's for doing across the network system administration. Lets you send shell scripts, lets you send packages. I actually couldn't even get a screenshot of it being used because I haven't used it in a while. But a tool that I think I would be remiss not to mention. So, okay, that's a lot of non-security tools. But let's get some actual security tools that are going to be useful. This is kind of the meat, the bread and butter. This is what this talk's really about. OSX collector. The first tool I'd say if you're getting into incident response on a Mac is OSX collector. This was built actually by the security team at Yelp. They've done some really awesome stuff as far as building really well-engineered small tools that are really helpful from an incident response perspective. They actually based this off of a tool called OSX Hunter, which was written by Jean-Philippe from Société Générale. Took me a while to make sure I was saying that in French right. And they just applied some better software engineering to it. And OSX Collector is a live response tool for OSX. So run on the machine, it grabs everything out of common logging directories, grabs a ton of information about the system state, what wireless networks you have, what's in the downloads directory, what's in the home directory, a ton of different plist files that are going to be useful. And then lets you take all of that directly off that host to analyze somewhere else. As if that wasn't useful enough, they then built a series of filters that you can run against your OS query output to do things like, hey, why don't we check every PDF we have, or every file path we have against virus total, just to see what pops up. Run all IP addresses in Etsy hosts against OpenDNS to see if they flag it as malicious. Just automates a bunch of that stuff that you'd want to do yourself, and makes it super easy to work with. Really basic. There's literally nothing but optional arguments. And then at the end, you get a big JSON blob. I ran mine through their output filter today, and I didn't check against virus total because I'm kind of cheap. I'm not cool like that. But apparently there's nothing wrong with my Mac right now, so that's awesome. I feel like I went really quick. Everybody get what I'm talking about with this? See where OSX Collector is super useful? You're going to go and run on your own Mac tonight? Or go buy a Mac and run on one tonight? I'm really helping you all out. That's just being useful. So that incidental, by the way, not Clip Art of hipsters. I actually know him. And that's Mike Rapine on Facebook. And he and a guy who goes by Theophilus have written a tool called OS Query. And in the same way that OSX Collector is probably one of the easiest, fastest, get value next day tools, OS Query is the one that's worth the investment. It's going to take you some time, but it's super useful. And so what OSX Collector is, and it works on OSX and on Linux, is it's a host instrumentation framework that exposes various characteristics of your operating system. Really clean interface, lets you store files, gets attributes, lets you timelining. Really a great tool for this type of work. I do pay for a couple tools that I think are super useful. Everybody's heard of Maltego, right? I don't know if you can describe Maltego effectively because it took me 10 minutes to write this slide. I didn't really know what to say about it. And I decided I think it's a mashup and pivot tool. If you ever use Maltego, it's for doing graphing of different types of data sets. Where it becomes really useful to me is when you're pulling in multiple different data sets all at once. So I made a GIF of me using it to actually analyze some stuff based on both GitHub's internal API, or sorry, external API, where I'm going to look at my own username and get all of my publicly available information. And it's a bunch of stuff out there. So you see it pulled off all the things that are on my GitHub profile, my name, my location. In fact, I don't have my email up there. And now I'm going to use a completely different data set. Now I'm actually going to use passive total, which does passive DNS and infrastructure analysis. And I didn't actually know what this command did, so it didn't do nearly as much as I hoped it would. But I ended up losing, I think it was their, was it domain categorization? Or get metadata, sorry. And all those would give me the two, TLD and the domain that I was on. And now I'm going to use a completely different data set and get what are the IP addresses associated with GitHub.io. And so having one tool that can pull from 3 different data sources and put it all together in one coherent graph movement is super useful for pulling internal APIs and comparing them against external APIs. And I try to make a lot of my workflow work through Maltego as opposed to pulling stuff together by hand and taking notes. I actually like it so much I wrote a blog post about how to write your own Maltego transforms, which you totally should do because I thought Maltego was useful on external data sets. Little did I know how much more useful it's going to be when I start dragging in external data sets or internal data sets. So we can take a series of 50 malicious IPs, throw them on a graph, and go, which one of these IPs have we seen user logins from? And instantly go to, okay, here are the 20 we have logins from, here are the 50 accounts that log in from those IPs, and start rotating from there. It was a game changer. An investigation that took me 12 hours, I was able to get down to something that I could do in 36 seconds. I don't know about malware analysis either. I just don't find myself having to. In a lot of cases, Mac malware is honestly a lot simpler. The iPhone SDK attack, they actually used a Perl script in a plist. Didn't take a lot of malware analysis to read through a Perl script. Look, reading Perl is basically malware analysis right off the bat. That seemed good. That one seemed good. Anyway, thank you. But when I'm looking for malware, Hopper is a Mac-centric disassembler and binary analysis tool. It's kind of halfway between being dev-focused and being security-focused, but super helpful for working through malicious binaries. A couple tools I feel like I have to mention for doing, working on the Mac. SleuthKit for doing dead disk forensics, Wireshark and TCP dump for network monitoring and packet analysis. OXCD is the hex editor I tend to go to. There's a bunch of others I'm sure I'm forgetting, but those are the ones that came to mind when I realized I'm going to catch all slide. If you want to get into doing more of this, some places I recommend going. Here are people I recommend following on Twitter. This is a pretty useful group. You'll recognize some of them, and some might be a little surprising. I have an evil twin. Sarah Edwards pretty much wrote the book on most of the concepts that I'm talking about. You're going to look at her stuff and realize how much that I ripped off, and that's fine. She deserves all the credit in the world. There are a couple sites. The second one's actually hers. First one is a little bit more exploitation focused, but has a lot of useful data. If you're going to get a book, get OS X and iOS internals. It's a little old, it's a little out of date, but it's still got some pretty solid information. Mac Hacker's Handbook and iOS Hacker's Handbook are useful, but they're a little bit more, again, exploitation focused. If you're going to take a course, Sans does it's the only Mac-centric course I really know. Are those beers impressive or what? Yeah, the red one, I think, so it really gets me. I found some links that I thought were really useful on hardening OS X systems. So, part of your incident response is going to be making sure it doesn't happen again. There's going to be some good ideas from here. In conclusion, we talked about some of the core concepts around OS X. As far as tools, if you're just getting started, I recommend OS X Collector, JQ, and Fear. As you advance your program a little bit, I recommend OS Query, Yara, and then spend some money on Maltego and Hopper. Obligatory plug, like everyone else on Earth, we're hiring people. We don't have any open spots right now that I know of, but we're definitely looking for people in the next few months. Thanks. Happy to answer any questions or anything like that. I really couldn't pick. I don't link to any. Honestly, I started doing some research on that and realized I don't have a whole lot of experience specifically with iOS tools. I've done it a couple times before. In most of the cases, though, where I've had to investigate anything around an iOS device, most of the artifacts have been sitting on the person's laptop already. There's some really cool stuff that Sarah Edwards has done around ubiquity, which is Apple's kind of how it wants to pass data back and forth between your Mac and your phone and your tablet and iCloud and all that. And there's a shocking amount of places where the data just kind of cross-contaminates without you needing to do a whole lot. Beyond that, iOS forensics has gotten really reliant on exploits, which they don't really tell you in a very straight-up way, but using stuff like Cellbrite. Cellbrite's compromising your iPhone so it can load its own driver so you can do a logical copy. Apple has put a ton of information, or a ton of resources and some very smart people since the whole post-Snowden thing of essentially making it much harder to compromise iOS devices. And that has basically come at the expense of all forensics tools because they were relying on similar exploits in those cases. So yeah, you're working a lot of side channel attacks, and it's not something I'm a terrible expert in, but I've usually found other ways to get the same data in most cases. Anybody else? Yeah, I'll post the slides on the Twitter a little bit later. So, no, answer. Cool. You're all OS X forensic or incident response experts. Awesome. Well, I have the last talk of that. Well, last non-keynote talk today. So I don't want to hold anybody up too much, but I'll be around. Thanks for coming. I appreciate it.